Hello friends, today we are going to discuss about the Laurents half-shape polarimeter. So Laurents half-shape polarimeter is an instrument, means polarimeter is an instrument used for determining the optical rotation of the solutions. When used for determining the quantity of sugar in a solution, it is called saccharimeter. So this is the construction of this Laurents half-shape polarimeter. This is the monochromatic source. This is the lens. This is N1 and N2. These are the nickel prisms. N1 act as a polarizer. N2 act as an analyzer. This is the half-shade plate. This is a glass tube which is containing the solution. This is the circular scale and this is the telescope type tip. So the polarimeter consists of this glass tube G for holding the solution under test held between two nickel prisms N1 and N2. Beyond the polarizing nickel prism N1, a half-shade plate, this HSP is the half-shade plate, is used for accurately adjusting the two nickel prisms for crossed position. Light from this monochromatic source S is made to parallel by the lens L and is incident on the polarizer N1. The light transmitted by the polarizer is plane polarized. The polarized beam then passes through the half-shade plate and then through the glass plate G. The light emerging from the solution will be incident on this analyzer N2. The light emerging from the analyzer is viewed with the help of this telescope. The rotation of the analyzer N2 can be measured with the help of this circular scale. To find the specific rotation, the specific rotation S is equal to theta upon L into C. Theta is the angle of rotation and C is the concentration. Specific rotation S is equal to theta upon L into C. Angle of rotation, C is the concentration, L is the length of the tube. So to find the specific rotation of the solution, the analyzer is first adjusted such that the field of view is completely dark. Then the glass tube filled with the solution and is held in position. The field of view now becomes illuminated. The field of view again made dark by rotating analyzer through a certain angle which gives the optical rotation of the solution, and the practical difficulty is in the determination of the exact position for which complete darkness is achieved. This difficulty is overcome by using the Laurents half-shade device. This is the quartz. So it consists of semicircular half wave plate ACB. This ACB is the half-shade plate of cords cemented to the semicircular plate ADB of glass. This is the cords and this is the glass. So optic axis of the wave plate is parallel to the line of the separation AB. The half wave plate introduces a phase difference of 180 degree between external ray and ordinary ray passing through it. The thickness of the glass plate is such that it transmits the same amount of light as done by the quartz half wave plate. One half of this incident light passes through this quartz plate ACB and the other half glass plate ADB. The light after passing through the polarizer is incident normally on the half shade plate and has vibrations along OP On passing through the glass, half of the vibrations will remain along OP, but on passing through the chord's half, the vibrations will split into extraordinary ray and ordinary ray. The ordinary vibrations are along OD. So this is about the, this is the glass, half part is glass, this is the O point, this ACB is the chords and ADB is the glass plate. So the in effect the half wave plate turns the plane of polarization of incident light through an angle 2 theta parallel to OP. The plane polarized light emerging from the glass plate will pass through the glass plate of half shade plate. That part appears brighter. So the on the other hand, light coming out from the quartz plate is partially obstructed and corresponding field of view appears less bright. If the principal plane of the L2 is parallel to OQ, the quartz half will appear brighter than the glass half. Thus, the two halves of the plate are unequally illuminated. When the principal plane N2 is parallel to AB, two halves appear equally bright. When it is parallel to CD, the two halves are equally bright. So to find the specific rotation of the solution, the analyzer is first set in the position for equal darkness without solution in the tube G. The reading on the circular scale is noted. Then the tube is filled with optically active solution of known concentration. The field of view is normally practically illuminated. The analyzer is rotated till the field of view becomes equally dark. The reading on the circular scale is noted again. The difference between the two scale readings gives the angle of rotation of the plane of polarization caused by the solution. By using the formula, specific rotation S is equal to theta upon L into C. Theta is the angle of rotation and C is the concentration, L is the length of the tube. So if the actual experiment different concentration of the solution are taken, the corresponding angles of rotation are dependent. A graph is plotted between concentration C and the angle of rotation. It is a straight line. So this is about the Laurents half shade polarimeter. This is the construction of this half shade polarimeter. This is the formula for the to determine the specific rotation. S equal to theta upon L into the C. And then in the construction, this is the monochromatic source. This is the lens capital L, which makes the beam parallel. This is the polarizer. N1 and N2 are the Nicol prisms. This N1 act as a polarizer, N2 act as a analyzer. This is the half shade plate which is kept behind this N1. This is a glass tube G containing the solution. This is the circular scale and this is the telescope capital T. This is the graph for the various concentrations. So when we plot the graph between concentration and the angle of rotation, it is a straight line. So this is for the half shade part for the this is the chords and this is the glass. This ACB is the chords plate and ADB is the glass plate. And by knowing the values of theta, L and C, we can determine the value of specific rotation. So this is about the Laurents half shade polarimeter. Thank you.